Hello everyone, hopefully you guys have had a wonderful and restful Easter break. I know that I've been naturally just going ahead here, taking care of some stuff I didn't get a chance to do while we had this disruption. This week actually focuses more onto waves, so we're jumping back onto that. As I said before, after this was the original plan afterwards, after we did your energy project. Unfortunately, I do not think that things are going to be looking so great for that right now. So don't worry about the energy project for now. Right now, though, we are going to worry about waves, and specifically, how does an earthquake transfer its energy throughout an entire state? Those of you who felt the Ridgemont quake this year, that's probably going to be one of our central focuses for this unit. Looking into how all that energy got from Ridgecrest down to here in Southern California. So that's kind of our thing. Originally, my plan would have been for you to play with the classic Slinky and actually see some of these things with wave behavior. Unfortunately, I don't have a Slinky right now on me to help you demonstrate it. I also know that you probably don't have a Slinky there at home to go ahead and help you with that demonstration. Therefore, I've compiled a few YouTube videos that you guys should take a look at. Just see what the instructor does in terms of these Slinkies and just see some of the properties of the waves as they kind of go through. What's important to keep in mind, though, is that the Slinky is a very unique object. It always wants to go ahead and come back to form. It's your normal spring, right? If you go ahead and stretch it, as I told you before, the laws that actually dictate the spring, Hooke's law, makes it want to go ahead and return back to its original shape. It's a form of inertia in a sort of way, okay? So you think about it, you stretch it out, and it's going to want to come back. If you compress it, it's going to want to go ahead and spring back up. Okay? So this is kind of the entire idea. You're going to see these waves always try to go ahead and go through an area, energy be affecting them, but they always kind of want to go back to the way they were. Okay? Inertia is trying to take hold and fighting back against this resistance of a force that's being pushed. Okay? That's kind of the idea behind a spring. How are you going to experiment with this, though, even though you don't have a Slinky, is through another object that I think is a lot more simple. A lot of you may have heard about my gummy bear lab in the past. Unfortunately, this may have to go without gummy bears. I may not be able to go ahead and support you there, but you are going to be actually building the base experiment. It's actually very simple. Just notice, very simple here. I just made it with a few sticks and a very, very long piece of tape held up about two ends, okay? I'll be talking more about this and how I want you to approach this experiment later, but this is basically the basics of what you're going to do. There's going to be three things to do this week. Number one, there's going to be a quick just summary of just some of your observations in terms of what do you notice about the instructor's videos. What do you notice about the YouTube videos with the spring and the Slinky? There also is a FET attached to that, so you can go ahead and try out making your own waves in the same way that I would have made you do them. So just go ahead, try those out. There is a bit of a form attached. And then secondly, you're going to be building one of your own of these. And there is a lab, obviously, to do it. We're going to try to do as much of that lab as possible. So you are going to go ahead and actually be building one of these and posting it into a photo gallery. And then after, you're going to describe on what you're determining, what you want to go ahead and find out with your own personal wave machine, which I find very cool. Okay? Hopefully the YouTube video will explain it better than I could. Alright, have a nice day everyone. Enjoy yourselves.